the unit. We discussed about the degree of a polynomial, also about zero of a linear polynomial and a quadratic polynomial as well as cubic polynomial, right? The zero means, what is that zero actually? What is the graphical interpretation or graphical meaning of zero? Can anyone tell me? Yes, it is actually the point at which the graph intersects the x-axis, right? If it is a linear polynomial, then it will have zero at the max. Zero, maximum number of zero it can have is 1. If it is quadratic, then it can have two number of zeros at the max, at most. If it is cubic, then it can have at most 3 number of zeros. I hope you guys are completely familiar with this thing, right? Zeros. Okay, any doubts there? I hope you guys know everyone clear with that, so that we can proceed with the next part, that is relationship between zeros and coefficients of a polynomial. Relationship between zeros and coefficients of a polynomial. Let me take one example. P of x is equal to 3x square plus 5x minus 2. How do we find the factors? Just by the method of splitting, right? This can be, the factors can be found out by the method of splitting. Like, we can find out this is, we just look at these two terms, that is 6x square. 6x square can be written as 3x 2x, this is minus 6x square. Or we can, sorry, this one, 6 into 1, x minus and plus. This is 3x square minus sorry, plus minus, right? This is plus 6x minus x minus 2 and 3x x plus 2 minus 1 into x plus 2, further x plus 2 into 3x minus 1. The value of this polynomial, it will be 0 when either of the terms, like either x plus 2 is equal to 0 or 3x minus 1 is equal to 0. That is, 3x minus 1 is equal to 0 or x plus 2 is equal to 0. Then we can write for x it is 1 by 3 or x is equal to minus 2. So these are the two zeros of this polynomial 3x square plus 5x minus 2. Therefore, zeros are 1 by 3 comma minus 2. Now, what if, now what is the relationship? We have found out the zeros, right? These are the zeros. Then the coefficients. What is the coefficients of x square x? What is the coefficient of x square? It is 3, right? Similarly, what is the coefficient of x? It is 5. Let us see how it is connected. These zeros are connected to the coefficients of this x square and x. For that, let us take sum of the zeros first. Sum of zeros. How much? 1 by 3 plus minus 2. What is the sum? It is minus 5 by 3. Got it? So this is the sum of the zeros. Similarly, the product of zeros, how much? 1 by 3 into minus 2. It is minus 2 by 3 minus 2 upon 3. Now, look at this. Sum of the zeros where you got minus 5 upon 3, and to carefully observe that what is 5 here? What is 5 here? It is coefficient of x, right? It is negative of minus of coefficient of x. We have the coefficient of x, that is plus 5, right? You can see here it is negative, minus into coefficient of x upon, also what is 3 here? What is 3? What is 3 here? It is coefficient of x square. It is 3 is coefficient of x square, right? This is the relationship between the zeros and the coefficient of that polynomial. Similarly, for the product of zeros, that is, we got minus 2 upon 3. What is 2 here? What is 2 here? It is constant term, right? Negative minus 2. This is constant term divided by or upon coefficient of x square. Got it? So we can say the relationship between the coefficient of a polynomial and the zeros of polynomials are in this way. That is, the sum of zeros, that is nothing but negative of coefficient of x upon coefficient of x square, and product of zeros are nothing but constant term, or the product of zeros will be equal to constant term upon coefficient of x square. And in general, in general, alpha and beta be the two zeros. These are the zeros of quadratic polynomial. Since a quadratic polynomial can have at the max only two zeros, right? So those two zeros, let us assume that they are alpha and beta. Then x minus alpha and x minus beta be the factors of the polynomial p of x, be the factors of polynomial p of x. Then ax square plus bx plus c is equal to k into alpha minus x minus alpha, x minus alpha into x minus beta, where this k is a constant or a constant term which is a constant one. On simplification, we can write k into x square minus alpha plus beta of x plus alpha into beta, or kx square minus k into alpha plus beta of x plus k alpha beta. Ax square plus bx plus c can be written in this form. And we can, on comparing the coefficients of x square x and constant terms, we can write for a, it is a. In the place of a, in the place of a, we have k, right? So for a is equal to k. And in the place of b, in the place of b, we have minus of k into alpha plus beta, minus k into alpha plus beta. Also, in the place of c here, in the place of c, we have the constant k alpha plus k alpha beta. It is k alpha beta. And in general, I can say alpha plus beta is equal to minus b upon a, and alpha into beta is equal to c upon a. So these are the two important things that you need to remember. Or I can write in general, sum of zeros alpha plus beta is equal to minus b upon a, which is equal to minus of coefficient of x upon coefficient of x square. And similarly, the product of zeros, that is alpha into beta, which is a constant term, upon coefficient of x square. sorry, a constant term, upon coefficient of x square. So these are the two things that you need to remember while solving the problems. Okay, is that clear? Any doubts? Okay. Fine. Let me take one more example. Find the zeros of the polynomial x square minus 3 and verify the relationship between the zeros and the coefficients. X square minus 3. So this is of the form x square minus 3. This is of the form a square minus b square. That is, you can write this as x square minus 3. This can be written as x minus square root of 3 into x plus square root of 3. Therefore, what are the zeros? Are x is equal to plus square root of 3 and x is equal to minus square root of 3. These are the zeros of this polynomial. Then sum of the zeros is equal to square root of root 3 minus square root of root 3. This is 0. Now, what is the formula we have? Negative of coefficient of x square upon coefficient of x upon coefficient of x square, right? For you can see this is x square plus 0x minus 3. The coefficient of x, it is 0. So this is 0 upon coefficient of x square, that is 1. Ultimately what you get is 0, right? Then the product of zeros is equal to root 3 into minus root 3. This you get as minus 3, which is constant term upon coefficient of x square. Look at here. This is the constant term minus 3 and the coefficient of x square is 1. This is what you got, minus 1 minus 3 upon 1. So this is how you solve, how you find the relationship between zeros and coefficient of polynomial. Here till here in the examples which I have given, I have shown that when you have a polynomial, you can find the zeros, right? What if zeros are given and you need to find the polynomial? That is how you can do is you need to find the quadratic polynomial and zeros are given as -3 and 2. For a quadratic polynomial, we know that it is of the form ax square bx plus 3, and we have the zeros. Those are alpha comma beta. We know the relationship, that is sum of zeros alpha plus beta, that is negative of minus of coefficient of x upon coefficient of x square. So alpha plus beta, how much? It is given as -3, right? That -3 can be written as minus b by a. This is nothing but -3 by 1. Also, alpha into beta, that is given as +2. We know that it is the constant term upon the coefficient of x square, that is c by a. This is again 2 by 1. So we have got a, b and c, that is a is equal to 1, b is equal to 3, also c is equal to 2. Can anyone tell me what is the polynomial now? What is the polynomial? Yes, quick. Just unmute. It will be quick. Otherwise, if you are going to type on the chat, it takes time.
X square plus 3x plus 2.
Yes, exactly. It will be x square plus 3x plus 2. This is the polynomial which fits the condition. Fine. And further, what if a cubic polynomial is given? What is the relationship between the zeros and that cubic polynomial? That will we'll study right now. So far, any doubts in quadratic polynomial? Okay. Others, any doubt? Fine. We know that cubic polynomial, that is of the form p of x is equal to ax cube plus bx square plus cx plus d. This is the general form, right? So let us take one example, that is p of x is equal to 2x cube minus 5x square minus 14x plus 8. And on simplification, we can find the zeros are on factorization. The zeros can be found out as x is equal to 4, x is equal to minus 2, and x is equal to 1 upon 2. These three are the zeros of that cubic polynomial. Then sum of zeros, that is equal to 4 plus minus 2 plus 1 upon 2. This we get 5 upon 2, which is equal to minus of minus 5 upon 2. And you can see this minus 5 is the coefficient of x square, right? And 2 2 is nothing but the coefficient of x cube. This is minus of coefficient of x square upon coefficient of x cube. Also, the product of zeros, that is 4 into minus 2 into 1 by 2. This is equal to minus 8 upon 2. This is nothing but 8 is the constant term here, right? This is the constant term. And cube, also this term, this 2, that is the coefficient of x cube. Sorry, I think this is supposed to be here minus 8. Okay, this should be minus 8. And here I can write minus of constant term divided by coefficient of x cube. So this is a relationship between zeros and the coefficient of cubic polynomials. And there is one more relationship that says sum of the products taken two at a time. If you take sum of the products which are taken two at a time, two at a time, that is, we have three zeros, right? 4, 2, minus 2, and 1 upon 2. First, we take the product of these two, then add it to the product of these two, then again we add it to the product of one, this and this, that is 4 into minus 2 plus minus 2 into 1 by 2 plus 1 by 2 into 4, which is equal to minus 8 minus 1 plus 2 is equal to minus 7. This can be written as minus 14 upon 2, which is nothing but this 14. Where is this 14? Here, right? 14 is the coefficient of x, that is minus of coefficient of x upon coefficient of x cube. So in general, I can write for a cubic polynomial of the form ax cubed plus bx square plus cx plus d, sum of the zeros alpha plus beta plus gamma is equal to minus b by a. Then the products of the two zeros taken two at a time, alpha into beta, beta into gamma plus gamma into alpha, which is equal to c upon a. Also, there is product of three zeros alpha, beta, gamma, which is equal to minus d by a. So these you must remember always. These are the important one. The first one is alpha plus beta plus gamma is equal to minus b by a. Second one is alpha into beta plus beta into gamma plus gamma into alpha, which is equal to c by a. And alpha into beta into gamma is equal to d up minus d upon a. So this is about the relationship between cubic polynomial and its zeros. Is that clear? Do I need to explain it again, or you guys have understood? So if yes, if everybody understood this, we can proceed with some of the exercise problems. Exercise 2.2. I'll pick up the second one. First mainly, second one. Find the zeros of the following the quadratic polynomials and verify the relationship between zeros and the coefficients. Given 4x square minus 4s plus 1. First, I need to factorize this and find out the zeros. This can be factorized as 2s, 2s, which is equal to 4s square minus 2s minus 2s plus 1 and 2s into 2s minus 1 minus 1 into 2s minus 1 is 2s minus 1 into 2s minus 1, and zeros are 1 by 2 comma 1 by 2. Now the sum of zeros, which is equal to 1 by 2 plus 1 by 2 is equal to 1, and I can write this as minus 4 upon 4, because this is equal to coefficient of, yes, you can see here the coefficient of s and s square, they both are 4 here. So coefficient of x upon coefficient of s square. Again, the product of zeros, that is equal to 1 by 2 into 1 by 2, which is 1 upon 4. You can see the constant term is 1 and the coefficient of s square is 4. Constant term upon coefficient of s square. Got it?
ಅಭಿ,
So
ನಾನು
this
ಆ
is
ಕಡೆ ಹೋಗಿರ್ತೇನೆ, ನೀನು ನಿನ್ನ ಹೋಸ್ಟ್ ಮಾಡಿರ್ತೇನೆ.
okay.
ಕೊನೆಗೆ ಮೀಟಿಂಗ್ ಅನ್ನು ಎಂಡ್ ಮಾಡಿಬಿಡ, ಆಯ್ತಾ?
ಸರಿ, ಓಕೆ ಓಕೆ. Here you can see the constant term upon coefficient of s square, and yes, please do the fourth one. Please do the fourth one, that is 4u square plus 8u, and tell me the zeros. What are the zeros of this polynomial? What are the zeros of this polynomial? Yes, quick. I'll give you 2 minutes. Anybody? Yes, how to find out the zeros? No, I didn't get any reply. I'll tell you. This can be simplified as 4u into u plus 2, right? Which is equal to 0. So taking 4u is equal to 0 and u plus 2 is equal to 0. Therefore, u is equal to 0 and u is equal to minus 2. These are the two zeros of this polynomial. And I can find this relationship as sum of zeros, 0 plus minus 2 is equal to minus 2, and I can write this as minus 8 upon 4. So minus 8, this is the coefficient of yes, the coefficient of u, and just a second. Uh, Wait. Then product is 0 into 2, which is 0 or 0 upon 4. This is the constant term by coefficient of u square. Uh, did I miss anything here? Because mm, the sum of zeros I'm getting here is minus, that is minus 8 by 4, but we have got the in the polynomial it is plus
ಯಾರು
8.
ಬಂದದ್ದು ಆ ಯಾಕೆ ನಮ್ಮ
ಯಾರು? ಮ್ಯೂಟ್ ಮಾಡಿ ಯಾರದು? Okay. Did I miss anything here? Because for u plus 2 and sum of zeros, 0 plus why I'm getting like this? Can anyone tell me? Yeah, it's correct. No, yeah, it's correct actually. I'm just confused. So this is minus of coefficient. Sorry. This is wait, minus 8. That minus 8 by 8 upon 4. We have for sum, it is minus of coefficient of x, right? So we have the coefficient of x as minus plus 8. So it will be obviously minus, and it is coefficient of x square. Clear? Is that clear? I just got confused bit. Okay. Are you guys taking notes, or you guys are just watching it and writing notes afterwards? How do you write the notes? How do you take the notes? Along, yeah, taking notes. Okay, you guys are quick then. If you are okay, if you want anything to be written again, that means if you have any points you have left out when you are writing, please let me know. Okay, I can pause you in between. And okay, fine. One more from the same exercise, and rest you need to take it as homework. Okay, the fifth one, that is t square minus 15. the zeros are t is equal to plus or minus 15, right? T is equal to plus 15 and one more zero is t is equal to minus 15. So these two are the zeros. Then sum of zeros, which is equal to square root of 15 plus minus square root of 15, which is equal to 0. This is t square plus 0t minus 15. So minus 0 by 1, which is nothing but negative of coefficient of t upon coefficient of t square. Also, the product zeros are square root of 15 into square root of minus 15. There you get 15 minus 15 upon 1, which is nothing but the constant term, negative of constant term, sorry, constant term itself, divided by coefficient of t square. Rest of the problems, that is first one and the third one as well as sixth one, first, third and sixth, these are homework for you. If there is any doubt, please let me know. Okay, then in the same exercise, the second main, that is find the quadratic polynomial, each with the given numbers as the sum and product of its zeros respectively. That is, they have given, they are given, we are given with the zeros of polynomial. We need to find out the complete equation, complete expression of that polynomial. The first one is 1 upon 4 and minus 1. We are aware of the fact that sum of zeros, that is equal to alpha plus beta. This gives us minus b by a, right? Also, this is nothing but 1 upon 4 minus 1. How much? How much is this? Or else simply we can instead of that, just a second, sum of zeros, that is alpha plus beta, and product of zeros, that is alpha into beta. The sum is given, so it is sum and products are given, not the alpha plus beta. Okay, the sum is 1 upon 4 and product is minus 1. It's very simple. Just we have the quadratic equation. We can write this as x square alpha plus beta x plus alpha beta is equal to 0. X square minus 1 upon 4x plus it is minus 1, which is equal to 0. On simplification, the denominator, we are taking the denominator, and on simplification, I can write x square, that is taking 4 as denominator. This will be 4x square minus